So an isomer is a molecule that has the same molecular formula but different structural formula. And they are broken down into 3 types. So they're broken up into chain isomers, positional isomers, and functional isomers. And those definitions are in the guidelines as well. You can look them up. And a chain isomer is basically that the chain is a different length, right? So for example, if we have hexane, we see that this chain is 6 carbons long versus 3-methyl pentane. So we see that these are isomers because they have the same molecular formula. This has the molecular formula of C6H14. This also has the molecular formula of C6H14. They are different because they have different chain lengths. They have different chains, right? But the molecular formula is exactly the same. So that's chain isomers. Okay, positional isomer is also very easy. It's when you have a normal organic molecule with a side chain or a haloalkane like this, right? And then this would be 3-chloropentane. And this one is 2-chloropentane. Because now instead of being on the 3rd carbon, the chlorine is on the 2nd carbon. And so positional is when the thing that is changing the molecule is just on a different number of carbon. It has a different address. So this is the thing that you're actually changing, the number to which the number of carbon to which the side thing belongs. So functional groups are also pretty simple because you only get 2 versions of them, or 2 pairs rather. So they either your aldehydes and your ketones, or they're your esters and your carboxylic acids. So this is a carboxylic acid, and its formula is C2O2H4. And so this is called your ethanoic acid. Right? So the name of your ester will be the isomer of this thing, the functional isomer. In other words, what is a functional isomer with the same formula? And the way that you draw that is you just basically, you draw an ester. So you know an ester has C with a double bond O connected to an O with another C. So that's your basic structure, and then you add in your hydrogens. So the way that you draw the functional isomer of an ethanoic acid, or to go backwards of from your ester to your carboxylic acid, or from your carboxylic acid to your ester, is you first identify how many carbons are there, right? And then you're going to put your oxygen in between them like this. So you have carbon 1, carbon 2, just like there are 2 carbons there. And then you rearrange your oxygens. And that's the reason why your oxygen can show you that you have a different type of isomer, a functional isomer. Because only your carboxylic acids and your esters, those are the only things that have 2 oxygens in it. That's why only they can be functional isomers. The other thing that can be a functional isomer is your ketones and your aldehydes. Let's do an example there. Oops. Ketones, aldehyde. So as you can see, this is a ketone, and its formula is C3H6, and there's an O in between, sorry. So C3OH6. It has the same number of carbons, oxygen, and 6 hydrogens. The aldehyde version of this would simply be, you're going to draw 3 carbons. There goes your H, because that's at the end, and then you have the same number of hydrogens.